In this lesson, we're going to use coordinate geometry to divide a line segment up proportionally, and it's typically called partitioning a line segment. So we're going to start off with a couple definitions. A directed line segment has both magnitude and direction. So it's also called a vector, but in this unit we're going to call it a directed line segment. That means it has a beginning and an end. So if I have a directed line segment and it's AB, we go left to right. That means it starts at A and ends at B. So it starts at A and ends at B. If I want to start at B, then I have to label it BA. So the start is at B and the end is at A. So the order matters because it depends on the location depends on where I start and how far away from the start I'm going to divide up this line segment. So partitioning. Partitioning is dividing a line segment into parts. So I take a line segment and I divide it up. Now there is a difference between ratio and scale factor. And we've talked about this before, but we're going to revisit it here. The ratio versus the scale factor. They are not the same thing. So let's look at a 1-to-1 ratio. A 1-to-1 ratio. That's going to divide a segment into two equal parts. So let's say I have segment AC or AB, and point C divides AB up into a 1-to-1 ratio. Alright, that means AC is equal to CB. Okay, that's the ratio. The scale factor, if I'm going to scale line AB down to length AC, the scale factor is 1/2. So, to find the scale factor, it's the first ratio over the sum. So the scale factor of AC, AC is AB scaled by the factor 1/2. So it would be the first ratio of AC. If it's 1-to-1, it would be the first ratio, which is 1, over the sum, 1 plus 1, which is 2. So the scale factor in this case, the scale factor is 1/2. So we'll just do a few conversions here. If I start with the ratio, I'm going to represent the corresponding scale factor, just so you understand what I'm talking about. Because quite often in the problem you're going to be given the ratio, but we have to use the scale factor. So we said the first one, a 1-to-1 ratio results in a scale factor of 1/2. If we have a 2-to-3 ratio, then that scale factor is going to be 2 over the sum of both of them, and that's going to be 2/5. A ratio of 1-to-7 yields a scale factor of 1/8. So hopefully you kind of get what we're doing here. A ratio of 2-to-1 is a scale factor of 2/3. So the numerator is the first number in the ratio, the denominator is the sum of the two. Alright, I'm going to speak in generalities, so this might be a little bit confusing until we do a numerical example, but I want to show you this so you kind of have a formula in your head, and then when you see the numbers it'll probably be a little bit better. So to partition a line segment given a ratio, you need to find the scale factor. And that finding the scale factor means you take the ratio and you use the numerator, the first number for the numerator, and the sum for the denominator. And whatever that scale factor is, I'm going to call it K. So let's say I have a line segment AB. So A is going to be at X sub A, Y sub A, and B is going to be at X sub B, Y sub B. A lot of letters here. So A is the beginning and B is the end of this line segment. A, B. Okay, I want to find the point along here that divides it under a certain ratio. So what I'm basically doing is taking the line segment, and I'm multiplying that length by the scale factor k, and that's going to shrink this down. But the way I do that is that I use the x values and the y values to do it. So, in order to find this location, I'm looking for this point here. Here's what I do. I separate it up. I have my x values and my y values. So my x values, my starting point is x of a. I'm starting here. So really, if I take this line, I start here, and I'm going to add the scaled version of this. I'm going to add the amount that's equal to this entire length multiplied by the scale factor, and that's going to get me at this point. I know it sounds confusing, but again, I need to talk about it first, and then I'll show you with numbers. So to do that, I take the scale factor and I multiply it by that length, which is the difference between my x values. And I do the same thing for y. I have a starting point, y sub a. To that, I'm going to add a scaled version of the entire y length. And that's going to give you a coordinate. You're going to get, this is the scaled version of the x coordinate, and this is the scaled version of the y coordinate. But it'll hopefully be a little bit better when I walk through some numerical examples next. Alright, so let's take a look at this. Given line segment AB, and A is 3, 2, and B is 7, 5, find the coordinates that partition the segment in the following ratios. So we're going to start with the same two numbers, or the same two locations, and we're going to divvy it up different ways. So the first one has a ratio of 1 to 1. The first step is to find the scale factor. If my ratio is 1 to 1, my scale factor is 1/2. So I'm basically taking the entire length AB and multiplying that distance by, or that length by 1/2 to get to my new coordinate. So to do that, I need a starting point. For the x values, my starting point is going to be the x value for A. So I start with 3, and to that I add the scale factor multiplied by the difference between the two, 7 minus 3, because that's how long that segment is in the x direction, 7 minus 3. So for x, I have 3 plus 7 minus 3 is 4, so 1/2 times 4, and I end up with 5. There's my x value. I do the same thing for y. I start at 2, so there's my starting value, and I'm going to add the scale factor multiplied by the difference, 5 minus 2. So that ends up being 2 plus 1/2 times 3, and I get 3.5. So the coordinate that divides that line up in half is 5 and 3.5. The second one, if I look at 2, 1, or 2 to 1, that means my scale factor is going to be 2 over 3. So I do the same thing. My starting point doesn't change. I still start at 3, and my difference doesn't change. The only thing that's changing is the scale factor. So my difference is still 7 minus 3, and I get 3 plus 2/3 times 4, which in the end gives me 17/3 for my x value. For my y value, I have 2 plus 2/3 times 5 minus 2, 2 plus 2/3 times 3, and I get 4. So this coordinate point is 17 over 3 and 4. That's the location of the point that divides AB up into a ratio of 2 to 1. So I'm 2/3 of the way along the line. So let's try another one. Remember, A, my point A is 3, 2, and B is 7, 5. So here, if my ratio is 3 to 2, my scale factor is going to be 3 over 5. My x value is 3 plus 3/5 times 7 minus 3, and I end up with 3 plus 12 over 5, which means I am at 27 over 5, and my y values, 2 plus 3/5 times 5 minus 2, 2 plus 9 over 5, and that ends up being 19 over 5. So you can get all sorts of fractional answers. It doesn't matter. 27 over 5, 19 over 5. If the decimal term terminates, you can rewrite it with a decimal. But there's the location that would divide AB up into a ratio of 3 to 2, which means you're scaling AB by a ratio of 3/5. So let's look at the next one. AB is drawn from 0, 10 to -7, -4. So A is the beginning. Find point C that partitions it in the ratio of 5 to 2. So again, the ratio is 5 to 2, which means the scale factor is 5 over 7. And then you do the process again. The x values, my starting point is 0, and my difference is going to be -7 minus 0. 0 plus, and this is 5 over 7, the scale factor, -7 minus 0. So I get 0 plus -5, so the x value is -5. The y value, my starting point is 10, and I'm going to add the scale factor times the difference, -4 minus 10, so plus 5 over 7 times -4 minus 10, and this is 10 plus, what is this, 10 plus -10, and that's 0. So this coordinate ends up being -5, 0. Alright, we'll look at one more and then we'll practice all this in class, because I know it can be a little bit confusing at first. I have line segment AB, and I want to find the point Z. So AB is in a ratio of 1 to 3, which means I want one part here and 3 over here. My scale factor then is going to be 1 over 4. So if I look at this, A has a coordinate of what? -1, 9. And B's coordinate is 7, -3. If I just look at this, what I'm doing is taking the x direction and I'm scaling it by 1/4. So whatever this distance is, I'm going to chop it into quarters and take the first quarter of it and add it to the starting point. So the starting point for my x value is -1. To that I'm adding 1/4 of 7 minus a -1, which is this length here, which is going to be 8. So 1/4 times 8. So my x dimension is going to be -1 plus 2, which should be 1. If I look here, this point Z should end up right there, because you still should be on the line. My y values, my starting point is 9 plus 1/4, the difference between the 9 and -3, because I'm up here and going all the way down there. So it's -3 minus 9, so it's -12. And I get 9 plus -3, so I should be at 6. So if you look, that is in fact the point. Point Z is 1, 6. And point Z divides line AB into a ratio of 1 to 3. So Z is 1/4 of the full length of AB. So this kind of shows you visually what we are doing. And we're going to work a lot more of these in class so you get more comfortable with this process.